All right, thanks everyone for coming. It's always a pleasure to come to Bologna. I was here 2 years ago. It was fun. So when I was accepted to talk again this year, I was very happy. This year I'm coming with a different topic. It's on Kubernetes. How many people are using containers and Kubernetes here? So quite a few. That's good. So this is going to be about what kind of things can go wrong on Kubernetes and how to monitor those failure points and make sure we have a more safe experience on Kubernetes. First of all, a little bit about myself. First, I'm Jorge Salamero. My official title is something like Technical Marketing Manager, but I consider myself a container gamer at Sysdig. It's a very cool role because it allows me to play with different kinds of technology and then go to conferences and show people what I learned. By the way, I'm hiring for someone for my team, so if you're interested in playing with Kubernetes containers, please talk to me after this talk. This is my Twitter, GitHub, and a bunch of things I like to do. How many people know Sysdig? Oh, quite a few. That's good. Some of you might know us because of our open source tools. Sysdig, Sysdig Inspect, or Sysdig Falco. We also have a commercial offering on monitoring and securing Kubernetes, but I'm not here today to speak about that. All it's related because most of this content is coming from our experience working with people deploying Kubernetes at a large scale. So we're looking at what kind of things can fail on Kubernetes. There are multiple layers. They are application, they are the hosts, they are the orchestration that Kubernetes does. Containers, even yourself can fail when working with Kubernetes. And we are going to look at 15 things that fall across these 5 different categories. I always like to start with what I call the holy metrics or the holy service metrics. There are many names for these. Some people call these KPIs, key performance indicators. Some other people, they call them business metrics. Other people, they call it synthetic monitoring or user metrics. At the end, this comes from the Google SRE book. They call it the 4 golden sign-offs, which are latency, traffic, errors, and saturation. These are like the minimum common metrics that you will find across any service out there. There are some modifications about this monitoring method or observability method. Brendan Gregg, who works at Netflix, came up with this naming where he defined 3 important metrics to look at monitoring: utilization, so how busy is our service, how close we are to 100% utilization, therefore we can start finding bottlenecks. Saturation, which is similar but slightly different, which is the amount of work that it's pending to be processed, to be done. And then errors. This philosophy of monitoring was great, it was revolutionary at the time, but it was mostly created or thought with CPU, with memory, with caches, with disk storage in mind. But when working with Kubernetes, we have almost the microservices, services that you talk to each other using HTTP connections. So Tom Wilkins came up with different terminology, similar but different, which is based on requests. How requests go into different microservices and how they behave. We can look at the rate, so the number of requests or connections, the errors that those connections they raise or the trigger, and the duration. How fast are we serving those requests? So with this, what's going on? There we go. So how we can get those metrics from our services? Well, most of the times, unfortunately, we need to do code instrumentation. That means well, it's the same thing when we use an API. We need to touch our applications, our code, and use different metrics protocols, StatC, JMX, or Prometheus metrics. We modify our code in a way that exposes those metrics. This is an example of Prometheus metrics implementation, which is my recommendation nowadays. If you are a Sysdig customer, we auto-discover those metrics automatically, but most of the times you will find yourself implementing these manually in your code. So here it goes, the first three metrics or typical failures you are going to see in applications. Connections per second, which is the metric net request count, depending on your monitoring system, response time, and errors. Those are, if you were to only monitor 3 things, this should be what you should be doing. But this is not specific from Kubernetes, you're going to say. You can see this in Prometheus, in Grafana, together with your Kubernetes metrics, but this is the same when using VMs or either physical machines. What happens when you see this, or when you want to see this inside Kubernetes? Well, Kubernetes takes care of orchestration your applications, as you know, but you don't know where those containers are running because Kubernetes takes care of scaling those across different hosts. Pieces are moving all the time, and the only way to put a little bit of sense on what's going on is to look at Kubernetes from a hierarchy point of view, where you can see your namespaces that typically they are applications, or different spaces like production or staging, the deployments, which typically are the different microservices you are deploying, the pods, which is the unit that Kubernetes uses to orchestrate the containers, and finally the containers themselves. So if we want to look at Kubernetes in a more efficient way, we need to look in parallel from a physical point of view in case we are looking at a host problem. But if we want to investigate a problem in a service, we need to be able to look at the containers aggregated by service, not by the host that they are running. So we need to have that possibility of pivoting between different views. How can we do that? Using labels, which is like Kubernetes metadata. This is an example with pods, but we have basically labeling in all Kubernetes resources. For example, here we have 2 different applications where we are applying app labels, tier labels, or role labels. And what we can leverage this metadata to aggregate based on any of these labels. Using these labels, they allow us to look at any of these metrics we saw before. For example, HTTP request counts, looking at them segmented by service, or we can segment by pod. The same metric can be analyzed from different points of view. But again, this is not different from VMs, where these things, where monitoring, where failures in Kubernetes starts to be different. All we have seen until now, like use method, the red method, it's basically based on the health of the service. Are those services working properly? But Kubernetes is modifying your services. It's scaling them up and down. It's deploying those services. So we need to understand the state. We need to know if we are looking at a caterpillar, or a cocoon, or into a butterfly, because it's only Kubernetes knows how things are working properly. So we need to look at the state. There is the only and most famous project for looking at the state of Kubernetes objects is KubeState metrics. The idea of this project is we query Kubernetes API, we understand how the different resources inside Kubernetes are behaving, and we generate metrics. Those metrics, you can fit them in your monitoring system of choice. Prometheus, Sysdig, even Zabbix or Signal if you're using those for Kubernetes. I don't care. Any time series database can be fed with KubeState metrics. So what is the first thing that Kubernetes does when it needs to run a container. It needs to find where is the best place to run that container. Which node is going to run that container? There are many ways that we can influence in the scheduling process in Kubernetes. Affinity, anti-affinity, taints, toleration, even we can write our own schedulers. Actually, we wrote a very nice blog post on writing your own. So it's very important to realize that this has come into a point where Kubernetes is not only handling where do you schedule the containers. So it's not a layer on top of your hardware, but the lines, the separation lines, they are not straight anymore. Kubernetes is handling the hardware, the resources of your cluster. So this is something we need to monitor, we need to look at. When doing capacity planning, we need those metrics that they are now Kubernetes resources, because a node, the computing node, is now a Kubernetes resources. So here it comes for point number 4, node availability. To look at this, we can either look at the availability of the host or look at the availability or the state of kubelet, which is a small component inside Kubernetes that takes care of instructing the Docker engine or whatever it's your container technology of creating those containers that it has been decided to be scheduled on that node. Probably number 1 metric here would be, it's my node ready to schedule new containers. All these are examples of PromSQL, which is the syntax used on Alert Manager, which is the alerting component in Prometheus. But you will see that I'm mixing different software for the different examples. So number 1 example is, do I have any node which is not ready? The second example is, do I have many nodes that they are not ready? Because having 1 node which is not ready could be fine, because we have multiple nodes and Kubernetes will start running the pod somewhere else. But if most of my nodes, they become unavailable, not ready, I'm going to have a serious problem very soon. We also need to look at if the the kubelet service is up and running, which is the third example. And number 4 example, it's similar to the first one. There are many reasons why a node cannot be available, cannot be ready. Can be out of disk, memory pressure when all the memory is busy and no new pods can be scheduled, disk pressure, or network problems. All those different metrics in earlier versions of QState metrics, they were different metrics. Now all of them, they have been consolidated in 1 single metric, which is node status condition, and then we apply different labeling. We can also use IUI. This is a Sysdig alerting UI to create this alert. I don't care what you use. But also, it's not enough to have the node available. We have seen that there are some situations where nodes are available, but they don't have enough resources to run the new pods. The way we define how many resources a container, a pod needs, is using exactly the syntax. Requests and limits. Request is the bare minimum requirements, what we ask from the computing node, and limits are obviously the resource limits we are imposing to that specific node. There is more on that link about a project for monitoring capacity planning on your entire cluster. But if you want to compare what you are currently using versus the capability or the capacity of your cluster, I suggest you look at these metrics. Because it's very important to make sure that we are sizing our cluster up to the requirements that our applications need. One thing which is not always obvious, and we need to take care when doing these maths and comparing things, is that capacity, it's not all the resources we have available for running pods. We need to keep always some memory and some CPU for operating system services, system D, cron D, all these things, and also obviously for kube system, kube internal services. So if you do the maths, allocatable metric is at the end what it's going to be ready for use inside for your pods or containers. So fifth and sixth, CPU and memory resources, we need to make sure we have enough to run pods in our cluster. And some people might think, well, we also need the storage, we need disk. Here things they get slightly more complicated because, well, at the beginning, like all containers, they were ephemeral. As you were killing the container, your storage system was gone, so we could monitor that properly. But Kubernetes came up with a feature called persistent volumes and its claims. And here things they got a little bit more complicated. So predicting if a computing node is going to run out of disk, it's easy using the expression. As we saw before, alerting if a node has run out of disk space is ready. It's easy. Looking at the ephemeral or the runtime partitions of a container, it's easy using container FS metrics. But if we want to look if any of our containers that they are using persistent storage, it's going to be tricky. You can look at LVM metrics that, by the way, they don't share if you haven't mounted the volume, so you need to do some scripting around it. You can use that, but at the moment there is no direct and obvious way of getting those metrics. Things are getting a little bit better with Kubernetes 1.8, and Control Manager exposes some metrics on persistent volumes and all the resources that your cluster might be using, because maybe you are not running your own storage, you are using EC2 or Azure or any cloud provider storage. You can still monitor those using the Control Manager metrics. So those metrics are exposed using Prometheus format, Prometheus metrics. So just see what's enabled in your cluster, but monitor that. So we have seen the applications. We have seen the node resources and capabilities. Now it comes the part which is completely new when using Kubernetes. And the way that Kubernetes orchestrates containers is using some of these resources. Replication controllers, replica sets, deployments, daemon sets, even stateful sets. Those they are different. They have some different features, but all of them they have in common that they are the way Kubernetes decides to run containers. So how many containers I need for this specific service? How should I schedule them? How it should behave when I'm applying an update? So this is basically one of the most important pieces inside Kubernetes, how I am deploying my applications. I'm just going to discuss the deployment, which is probably the most typical resource. And here, the most important question we need to ask ourselves is Kubernetes doing what it's supposed to do? If we are using a container orchestration tool, there is a new layer in our infrastructure that needs to be monitored. We cannot just trust Kubernetes and expect it working. So here comes the most obvious point to look at. Are we running the containers we are expected to see inside Kubernetes, inside that specific deployment? But that's not enough, because on Kubernetes, you don't run one instance, you run multiple instances. So you might say, okay, for this middleware service, I want to have 5 different instances. So are we running 5? Are we running 3? Are we running 2? We need to look at that, because that will have consequences on the 3 first metrics we saw. The number of connections we can serve and the response time. So here I'm showing two ways to look at this, in a graphical way using Sysdig, and command line way using Prometheus metrics. This is the important line you need to look at. Is the number of replicas or instances available different from the number of instances I have on my spec? This is what you need to look at. That's for my favorite Kubernetes alert. Okay, there are many different ways or reasons why this can change. Because we have nodes that they go down, and then we don't have free resources to schedule new pods, because we have updated our daemons head, and the new version is broken. Many things can go wrong here. And actually, very similar to that previous failure point is monitoring our deployments. Okay, so 3 things we need to look at the deployments. Number 1 is if Kubernetes API receiving my new manifest properly, and that can be monitored looking at these 2 QState metrics. The observed generation number needs to be equal to the metadata generation number. If it's different, something is going wrong. Another not very often suggested alert or metric to look at, but I like it very much, is my deployment pause. I have seen people pausing deployments when they were doing troubleshooting, completely forgetting about that, and then going nuts because Kubernetes was basically doing nothing. It's going to be very rare situation where you need to pause a deployment. So if that's happening, you want to see that in your monitoring dashboards, okay? Because you will forget. The third metric in this area, it's going to be the maximum number of unavailable instances. When I'm doing a rolling update, I'm basically deploying a new version while the other one is still running. There needs to be a minimum number of running instances to provide the service, or a maximum number of unavailable ones. So that's going to be important. We need to have this metric ready to do maths in our alerting compared with the other ones. Okay, so keep that in mind. So, okay, we have seen how Kubernetes it's deploying my containers, but how the containers are working themselves. Things that get a little bit more complicated as we are stacking more layers on top of other layers. And here we need to understand how Kubernetes instructs, in this case, the Docker engine to create a container. I got this graph from GitHub, sorry, I don't know to whom to give the credit, but I find it nice. The idea is we pull the image from the registry, we create the container gets into a pending status until we manage to start it, and then we can have it either ready. If Liveness proof says it's okay, I'll show you in a second what are those proofs, or if it times out or if it crashes, it can go into a fail status. If things fail all the time, we'll get into a special status called CrashLoopBackoff. We'll discuss that in a second. But it's very important when we need to look at how the containers are behaving, how they are working. It's very important to understand this lifecycle. There are many words, many terminology. So you go to the pod lifecycle documentation page, you have all the information there, but it's something you need to understand. And to look at the status of each container, Kubernetes has 2 helpers. Number 1 is liveness proofs. The idea here is that some containers, they are not able to crash when something goes wrong. Imagine we have, I don't know, an Nginx pod. When Nginx crashes, well, the container will be restarted automatically because it follows properly the Docker principle of one container, one single process, no wrappers around. But I'm pretty sure if you're using containers, you don't necessarily follow that principle in 100% of the occasions. So sometimes you find that you are running processes with supervisor-D inside containers, or you do some super hackish wrappers because you're bringing into Kubernetes some legacy applications. Whatever is the case, we are not going to discuss that. But Kubernetes provides some infrastructure to define that if an application running inside a container it's not working, I'm going to let kubelet that needs to kill that container and start it again. So that's the Liveness purpose. But there is another one which is more interesting in our case, while we are looking at the availability of the containers, which is the Ready-ness proofs. The idea here is that some containers that for some reason they might not be ready as soon as they start to start serving traffic. If it's I don't know, a database, because maybe it needs some warming up period and we need to fill in the cache to get that container ready. Maybe it's because we are running configuration management software inside the container and needs to configure a few things before getting that ready. It might be because, I don't know, 100 different reasons. But here we have the infrastructure, the feature to define when a deployment is orchestrating different pods, when should we tell the Kubernetes service that that container, that pod, is ready to start serving traffic. And this is what defines this check if the pod is available in a deployment or is not available. In the example before, I showed how to check this with HTTP GET. You can also do with an exec, and you can also do the check with a TCP socket. Okay, so 3 different ways of checking if a container is ready or not. So with this information, we are ready to look at the pod status, which is going to define if those pods they are available inside my deployment, but also when things go wrong. These metrics they are going to give me information on what kind of things are going wrong in some of my pods. So number one metric to look at is the status phase. So if we could get the container to run, or it's still pending because I don't know, I wrote a custom scheduler and Kubernetes wasn't able to schedule that container. If it succeeds and we have started, or if it failed. So there are multiple phases in that process of creating a new pod, and depending on the phase where that pod might be hanging, it's going to give us clues on what's failing. The status ready is the OK metric. If that says I'm ready, that's perfect. The other important metric is the schedule. If it's a schedule, the scheduling process is working fine. So we have resources, we have the nodes working properly, we could pull in the image, but we are going to see that sometimes pods, they have multiple containers. So similar metrics, they also exist at the container level and not at the pod level. So those are available as well. So point number 11, pod status. And with this, I wanted to do a separate case with pod restarts, which is probably the most difficult problem you're going to face when running Kubernetes. I have a pod, I have a container that running on the developer machine works perfectly, but then I get that into my production environment and things doesn't work as expected, even if people say, oh, Docker, it's very cool because you can run things in the same way in dev and in prod. Well, not always. So we need to look at restarts of your containers. There are 2 ways actually to look at this. We have metrics that will tell us how many times a pod has been restarted. We also have Docker and Kubernetes events that they tell us every time a container is created or crashes. So this is the example. of alert. This is actually a complete example of an alert configured in alert manager inside Kubernetes, inside Prometheus. And here's an example of how to create an alert looking at the numbers of events, in this case using Sysdig. I don't care. Different ways to look at the same problem. And actually, a small gap for a little spam here. Sysdig has an open source tool called Sysdig Inspect that allows to trigger a capture file that contains all the system calls that they are being executed in a host and browse through all those using a graphical UI. And this is awesome to troubleshoot CrashLoopBackoff problems. So totally recommend it, and it's free. Next section is Kubernetes internals. Kubernetes is basically like a Lego game. You can build, I don't know, thousands of millions of different combinations of components for creating different Kubernetes clusters. Probably there are no two equal Kubernetes clusters, well, unless you're using CloudFormation or things like that. But they are very, very different. And there are a few basic components you are going to find all the times, and some of the components that can be optional. You need to look at all of those. The API server could be the most important one. And the second one is going to be looking at your DNS, because it's something that fails very often. In the Kubernetes world, mesh services is the new hipster topic. So if you're using things like Istio, Linkerd, you need to monitor those, because basically your entire application is going to rely on those. Something that people doesn't monitor very frequently is the registry. Either if you're using Docker Hub, you're using CoreSQL, whatever, it's a very, very simple service. It's just an HTTP service. Could be Nginx, works very reliable, but if it fails, your entire cluster is going to go down. It's very simple, probably just a basic HTTP check, but don't forget about it, because if you don't have a registry, you won't be able to schedule new containers. At the end, any other special piece on your Kubernetes needs to be monitored. But I had to choose my favorites, so we go with number 13, the API server. You can use specific metrics from QState. The API server itself provides Prometheus metrics, but you can also treat your API service as any other HTTP microservice inside your cluster. So if you use the golden signals to monitor that, will be enough. So 3 different ways, really. But make sure your API endpoint responds to request fast enough, and it's not triggering errors. And then KubeDNS, Istio, whatever it is, whatever is your network layer, your DNS service. Most of the CNCF projects nowadays, they expose metrics using Prometheus format. So just scrape those, use Sysdig, whatever you want, but don't forget about those, because I'm get really, really scared when people, they have, I don't know, like a working Kubernetes cluster, everything, it's perfect, A grade, you did a very good job, and then they say, oh, let's try this new cool thing. And then suddenly the entire production reliability of the cluster goes to the trash, because they are not monitoring that fundamental component. Okay, so don't forget about that. If you're looking at monitoring Istio, that's a good link on a blog post we published, I think it was last week, on how to monitor Istio. It's going to be very important. It is super easy. Prometheus metrics, even open tracing metrics, they get available out of the box. So very little work for you to do, but you still need to do it. Finally, oh, perfect timing. The last point of failure is going to be always the human part, okay? What are we deploying? I don't care if you have a CI/CD pipeline, super hipster DevOps procedures to deploy your applications, or you are just deploying things manually. I don't care if you run kubectl with a wrong manifest, or you commit a wrong manifest into your GitLab or GitHub. You need to validate everything that a human does. So there are a few options for that. Matthew wrote QEval, which I don't know how anyone didn't come up with something like this before. We validate YAML. YAML is not great at syntax, but it's very easy to read. That's a different word anyway. But we need to validate YAML because I don't know, we miss a space, we miss a tab, things go funny. Humans, we don't see that, and then we go to deploy and it breaks and broken. The other typical failure point can be, we have modified something manually in our cluster, and then for some reason I see the files and manifests that they were committed into the Git repository, but then Kubernetes is running something else. What the hell is going on? So we also need another piece of software that validates that the same thing that we have in our manifests is the same thing that Kubernetes is expected to execute. Okay, this goes very tight together with that other alert I showed you before. Has Kubernetes understood your manifest update properly? Okay, but they are different failure points. One was Kubernetes failure point, this is human failure point. So kubedev allows to monitor that basically, and you can run that as a pod inside your Kubernetes cluster and check against your Git repository. There is an entire whole discussion about configuration and reconciliation in that link, but this is still a very new discussion. All these things, I foresee this area becoming more and more automated. Like right now, for example, we are used to define how many instances do we need for every deployment manually. But I see more and more people adopting horizontal autoscalers and autoscaling GrUSP for your instances. So this is going to become more and more automated. So things might change in the future. So little recap. My 15 favorites failure points inside Kubernetes, the applications, and we need to look at connections, response time, errors. My resources, so node availability, CPU, memory, disk, and other cloud external resources. How Kubernetes is deploying my containers, the orchestration layer, so the number of running instances against the desired number of instances, and update glitches. And finally, the pod orchestration, so the status, the restarts, the health. In this case, we are going back to the beginning, health of services rather than the state of services. So the health of APIserver, the health of your DNS server, and the final one, human factor, monitor your commands, your configuration. So this is everything I have for today. We have a few minutes more for questions. So. Thank you.